Hi everyone. Again, welcome to this lecture of the Linux programming class. Today we are going to actually talk about some examples on Python. We went through an extensive study of Python in the last several lectures, culminating in the CGI programming essentially. So today we are going to just look at some of the programs, how to write it in Python, and then I'll just go through the examples and give you some hints, and then pretty much like all that we have already learned, and then if if you have any more questions, the TAs can answer those questions. So the first one is actually a program on the conditionals, for example the if statement here. So the here we are going to actually all these programs are here in this particular website. You can go there and look at it. These are basically the Python or Pygame programs essentially. And then in this particular program, basically we have like several variables. So the variable A, that's defined as 4, B that is defined as 5, C defined as 6, and once we have these three variables defined, now we can do some basic comparisons. We can see that actually so the first statement is if A less than B, then we just print A less than B. If A is greater than B, then print A is greater than B. So in this case, which one do you think will be printed out? So obviously like this. So we should look for this one. A is less than B, and then if A is less than or equal to B, then it prints out A less than or equal to B. And we have all these things defined here. So let's see how the program actually outputs. Now let's see. Let's scroll a little bit down. So if A is greater than or equal to B, then it prints A greater than or equal to B. So simple program. And then you can see that basically like it follows our original convention, like this is the expression, and then the colon actually separates, and then there is an intent for the print statement, and then after that the print actually is there, so that all the intended ones are part of this if statement. Now the equal, double equal to, and equal, there is a tendency to mix them, and you know that actually like equal to is an assignment, and the double equal to is a logical check essentially. So that is what is in this comments, and as you know, like all these things should be comments, treated as comments as well. So if A equal B, which is basically like a logical check whether it is an equal to, then print this, and the not equal to is as you know, it is the bang and then equal to. If it is not equal to, then it will print this. Now if A is less than B and A is less than C, then it prints out this one. Then a non-exclusive is A less than B or A less than C, then print this one. Now there's a Boolean data type which is A equal to true, and then this is actually legal. So again, you can do this assignment, A equal to true, and then if A, then print A is true, which is what it is going to be. And then if not A, then print A is false. So now if A is equal to true and B is equal to false, and then if A and B, then print A and B both are true. We make another few more assignments. A equal to 3, B equal to 3, and C equals A equal B. So now then print C. So now let's see what that will output. And then as you know, like I mean in Python, 1 is actually a true value. So if 1 print 1, if A print A. So anything that is 0 is actually what is the false essentially. So and then we also do this, if 0 then print 0, and this will not trigger because the 0 is false. So this expression is false, so it will never go into this. Now another comparison, comparing variables to multiple values. The first if statement, basically like here in this one it will appear to work, but it will always trigger as true even if the variable A is not equal to B. This is because B itself is considered true, just B alone. So A equal to C, if A equal B or B, then print A equal to B maybe. So basically like even if A is not equal to B, this will be triggered because or B is basically like always true, which is non-zero. The proper way to put it is basically like we need to say A equal B or A equal the lowercase b, then it will never get triggered. So now the other one, basically the temperature equal to int input, what is the temperature in Fahrenheit. So now you know that actually like input is query to get a value from the screen, and then this is the question, and essentially like I mean whatever the number that you type in, it is converted into the integer data type, and then that is assigned to temperature. And then if temperature is greater than 90, then print it's hot outside, and then it prints done. So you see basically like again this goes with the print statement goes with the if, and then the other print is actually stays outside. So whether this is true or false, basically like this print done will always be performed. And then there is an else clause that you can define. So and else is also like colon and then print it is not hot outside, and then again print done. Now the else if statement, which is the third category, this is also like we saw. Essentially here we define the if statement, then the else if statement, and then finally the else if statement. And here note that actually the else if after this is the second conditional, which is temperature less than 30, and then we need to put a colon after that. So with after each of the expressions we put a colon to denote that basically that is the end of the expression, and then the remaining ones are the block of code that needs to be done. Now the ordering of statements basically, so temperature basically this is the one, and then it's hot outside, which is greater than 110, then oh man you could fry eggs in the payment. So what is the mistake here? If you look at it basically like if it is greater than 90, it says it's hot outside. Then only if this condition is false, then it will go into the next one. So if it is greater than 90, it will print this, and then it will exit out. So this condition will never get executed. So in this one the proper ordering should be like, I mean, this should be first one, then that, then the 30, and then it's okay outside and then come out. So let's see what are the things basically. So the first one we saw that it's A is less than B, so it prints out just A is less than B, does not print out the actual values itself. Even though we assigned A as 4, B as 5, etc., it just prints A less than B. That's because we didn't put the values as an output value. So in the same thing, how do we make sure that these things can be output as values? For that, we need to make sure that these are like the percentage B's and things like that, and then and comma after the quotes we need to specify A and B so that the values themselves get printed. So this is all the various command output. I want you to go through this basically along with this particular all the programs. This program pretty much, I mean, it exercises the if then sorry, if else if else conditionals pretty well, including all the different expressions as well. Gives you a good understanding of all the logical operations that you can perform. So now let's go to the next one, which is the program to calculate the kinetic energy. So first of all, what is the equation for kinetic energy for a moving object? So basically we compute it as the mass times velocity squared. So and then times half basically. So half times mass times velocity squared. That's the equation for computing the kinetic energy. So we need to take the input as the mass, and this is a floating point number. Then we also need to input the object's speed, and then we'll say basically that's the units we define. Basically these are all in the MKS units or the SI unit essentially. You are familiar with those kind of terms. So the SI unit, basically the mass unit is kilograms, and then the speed or the velocity unit is in meters per second. So in this example, we start by saying that basically, okay, what does this program do? Like just a documentation line, which is this program calculates the kinetic energy of a moving object. So now we define a variable m string, and this is the floating point, and then this is where we input the mass of the body basically. So enter the object's mass in kilograms, and then we leave it, and then we call it as an input, and then we assign it to the float data type. So now this basically this results in the prompt, and then somebody has to enter in the screen a particular number, and then that is getting that gets assigned to the string in the form of a floating point number. Let's not worry about the comments here. The comments is essentially like, I mean, if you miss this float here, you can always have this as a separate one. So that's what this comment stands for. Now to get the speed of this particular object, we define another variable called v string, and then v string is also a float, and then here we get the speed in meters per second. And then once we have these two numbers, we can simply calculate the kinetic energy, half times the mass times velocity squared. And then now we need to just output this one in the form of a string. So see that basically the E is currently it's a floating point. We need to convert it into a string in order to display this. So to convert that into a string, we basically use the strE function. And then here what we are doing is basically like print first this particular phrase the object has, and then we add the string E, and then we also then print the remaining ones, which is the joules of energy. So here one simple example, we enter the mass in kilograms 30, object speed in meters per second 5, and then the outcomes basically 375 joules of energy, and this is computed basically half times 30, 15 times 25, and then that's this number. So pretty straightforward. You can also construct this in a different way where we can say basically like the object has, and then the percentage D or percentage F kind of formatting string, and then comma directly give the E and then close parenthesis, and that will directly print the value as a string, as a floating point number itself. It need not convert that into a string and then put the value out. And then you can see that actually like it is converting it into a string because I mean it's actually computing in the floating point, because these ones presumably can be an integer, but you know the output is actually like 375.0. And then again if you don't specify this as a floating point and instead say integer here, you're still going to get a floating point number for the energy. Can you tell me why? Because if you remember actually like this is the same thing that happened even in Tcl. The starting number is a float, and then all the remaining ones are automatically adjusted to that particular data type in order to compute that number. So even if we take the M string as integer, it will still result in the same thing. The only thing here is we cannot put this as a string itself. We have to take this as an integer or a floating point number. So I would urge you to try actually like change this float here to int, and then this float to int, and then try this program. It should run exactly the same way. Okay, so now we go to the next one, which is a program for a simple encryption. So the encryption essentially is we change the value of a text to a different one, and we kind of encrypt the text essentially. So there is a simple algorithm here. We'll probably use this. We have a plain text, which is this is the phrase that we are going to encrypt. So here you can specify anything basically for testing purposes, but make sure that you use the encryption and then the decryption followed by that in order to verify whether your encryption program is working correctly. So the plain text is a string, which is this is the test ABC. The encrypted text we define as an empty string. So quote which is denotes the empty string. Now we start reading each character at a time from the plain text. So for C in plain text, so we define X is the ORD of C essentially, and then we essentially we just say basically X is X plus 1, and then we dump out a new character which is the character X basically. And then the encrypted text is nothing but basically we just add this C2 to it, to the encrypted text, basically append it one by one. And then once this loop finishes, we just print out the encrypted text. So let's see how this works. So again, the particular text is essentially like this is a test ABC ABC. So the ORD function, as you know, basically just gives you in the alphabetical order where this particular character is, and then this is plus 1 is basically the next character is what it's going to give. So this becomes UIJT, which is U is next to T, I is next to H, J is next to I, and then T is next to S. And then wherever there is a space, basically the next character is the bang. So that is what gets printed out. And then where is the full stop? It's the slash. The next one is slash. So these are all the ASCII characters from the ASCII text. So now this works, and then we have some encrypted character set. Now let's do, how do we decrypt this one? It's fairly simple. We capture this one now. This is our new string, and then we go for the odd of this one, and then just reverse this one. Reverse that is X is X minus 1, and then we create the character set based on that. So let's see how the program works. So as I mentioned, we have the encrypted text. Then we say basically we go and find out the ordinal of a particular character, and then we basically say X is X minus 1, and then we build the character set, and then we output that. So now when we decrypt this particular string, we get back our original string, which is this is a test ABC ABC. I think this one is pretty interesting and pretty straightforward. You can actually try with new stuff, and in fact what you should do is you should put both these programs into a single program, and instead of actually defining this as a string, you should get this string from the command line, and then you can have fun with it. As to, you can first output the encrypted string, that is print the encrypted text, and then later on you yourself can decrypt that and then print the decrypted string. And then something else to try is basically how do you instead of the encoding algorithm as the X is equal to X plus 1, try new ones, basically meaning X equal to X plus 5 or something basically, and see how that works. So these are all like some of the fun things that you can do with this program. So I want you to experiment with it, and then so that you feel more comfortable running the Python programs. Okay, so the next one is a program for exception handling. This is something that we saw, like how to handle the exceptions, and in fact the same thing like the try and except were the commands that we saw. So here we have to import this particular package, the system that we also like learned about how to import this in pretty much like last but one lecture I think. So first we will find out what the divide by 0 error is. So we define try and then x equal to 5 divided by 0 except now we say print error dividing by 0 and then we give also like a exception info basically like 0. So it needs to print this particular exe info 0th one. So we will see like how that gets printed out. And then there are some more things basically like an invalid number conversion. So if you say like int Fred and that is assigned to x, so here we say basically like error converting Fred to a number, and then we also like gives another system exception, and then so number entered equal to false, while the number entered equal to false, number string is input enter an integer. So here we are actually like converting the number string to an integer, and then number entered equal to true, and then if it is not, then we'll say basically like error invalid integer. And then opening file types of error f equal to open my file dot text, and then basically like if that file cannot be opened, then it prints out error opening file. And then all these things can be combined basically. So if say basically f equal to open my file text, s is equal to f dot read line. So you know about this object and basically its method, the read lines method, and then I equal to int f dot strip, that's another method, and then the x is equal to 101 divided by I. Now you can print many of these exception errors, IO error, value error, zero division error, and then some unexpected errors. So now to generate exceptions, essentially like this is another function that we are defining, basically get input, and then user input is input something, and then if the length is 0, that is like if user is not entering anything, basically then we just say IO error, user entered nothing. So now let's look at what are the outputs. So the first one we actually did the divided by 0. So the first one was the 5 divided by 0. For that we get the error dividing by 0, and then also it since it we also like went to the system info system package for the particular exception, it gives the exception info as a 0 division error. Now when we try to convert Fred to the number, we get a value error as the main error. Now when we try to enter the integer number, then try to convert that into an, or we ask the user to enter, so the user enters 5, and then this is essentially like it's basically it goes through basically, because there is no error, so it's a valid integer, so it goes through. If you put anything something invalid, then it will catch the invalid integer error. Now the opening the myfile.txt, essentially that's not there, so basically it just prints error opening file. Now these are the things where we had the multiple ones essentially. So for the opening file, basically, like I mean, before that actually, so there's a IO error. So in this one, essentially, like I mean, it's mainly the so we had multiple error cases, and the only thing there is essentially, like I mean, it's when it is reading the line, it has nothing basically, so it is more like an IO error. That's what gets output, but it could be so if there is a value, and then if the value is 0, then we could have gotten a 0 division error, and if something else has happened, then basically it can also come out with an unexpected error. Now the next one is basically, like we say, like enter something which is 7, and then this one basically, like I mean, it can the user inputs length is 0, and then it can give these kind of errors basically when we try to run the get input. So that's a brief look in the exception generation. Now the next one is program on lists. Let's see. So this particular program is taken from the Google's Python class. So again, you can go into this particular website. This gives you the Python class, and basically like there are several examples there. So we will talk about few of them. So here the main thing is the first one that we are going to look at it is the matching the ends. So given a list of strings, return the count of number of strings where the string length is 2 or more, and the first and the last characters of the string are exactly the same. So one thing to notice, Python does not have this increment operator that is plus plus. It only has an incremental assignment which is plus equal to. So keep in mind about that, and that's what we will use. So this particular function is called match ends, and then the arguments are words. So we define a counter essentially like a variable is 0, and then for word in words essentially like for each of the words we basically see if the length of word is greater than or equal to 2, and if the first one is not the same as the last one minus 1 actually. So we already studied these notations, like word 0 represents actually the first element of the character of the string, and then word minus 1 represents 1 from the last one, and then the last is just specified as last. Actually like yeah, this denotes the last character essentially the minus 1. So if this is the same, then we increase the count and then we found our word essentially. So we just return the count for how many such things can exist. So we will see like output of these kind of programs later. Now the second one is actually it's called front underscore x, which is the list of strings. Return a list with the strings in sorted order. Each except the group all the strings that begin with x first. So if you have like mix XYZ Apple Xanadu Aardvark, it results in Xanadu XYZ Aardvark Apple and mix. So here the hint is basically like we can do it by making two lists and sorting each of them before combining them. And do you know like I mean so one list is the all the words that begin with X, and then the second one is the regular sorted one, and then we can actually combine the things. So the way we will do it is basically like all the things. So it's actually all the things that start with X and all the things that does not or do not start with X. So those are the two lists that we will make. So it's called front underscore X, and then again we'll pass the list of words. So we say basically X list and other list, those are the two lists that we maintain. So we define them as the empty list, and then if the W starts with X basically, so we know that start with is a method which can be applied to this W object, which is a word inside the list. So then we basically append this word into the X list. If it is not true, then we'll append the word to the other list. So simple basically. So X list dot append W else other list dot append W, and then once we have this, then we just sort the X list separately and then sort the other list separately. So what we return actually is sorted X list plus sorted other list. So again very simple, as you can see basically it was only like 1 2 3 4 5 6 7 8 lines, and then we could achieve those things. Now the next example is to extract the last element from a tuple used for custom sorting. So the last element is denoted as, we know that it's -1. So we basically like get the last one, and then that's it pretty much. Then the next program is basically to sort last essentially. So given the list of non-empty tuples, return a list sorted in the increasing order by the last element of the tuple. that means basically we have if it is 1 7 1 3 3 4 5 2 2, then it started on the last element, which is 2 2 1 3 3 4 5 and 1 7. So here the way that we will be using is basically we are using a custom key equal to function to extract the last element from each of the tuples. So let's see how it is written. So again, it's just the 2 lines. So sort list tuples is the function, and then basically what we do is return sorted tuples and then where key equal to last, very easily just written. So now let's see the next one, which is test function used in main to print, basically print what each function returns versus what it is supposed to return. So we define this function called test got and expected. Those are the 2 things. If got equal to expected, then we will prefix with OK, else we will prefix with not OK, which is X. So here we say basically like print X percentage S got and percentage S expected, and we define this basically like as prefix, and then what is we get, and then report what we get and what we expected. So in order to test all these functions that we defined earlier, we will give like n number of programs, and then basically we'll call this program multiple times with various arguments, and then test whether this holds good. So the first one we will be testing the match ends. For that we give like various various strings basically like inside a list, and then we'll test it out, and then we'll apply various scenarios to test it. We'll also test the front X here, and then we'll also test the sort last one. So for the match ends, pretty much we got perfect. So let's look at our test vehicle and see basically whether we can do the thing. So the first one is actually it identified 3 such matches. So can we identify 3 such matches? One is okay, this is one, this is the other one, and the third one is here. So anything it is over, I mean 2 or more is basically is our target, and then the first one is equal to last one, because that's the thing. So we know that actually in this list there are 3, and then that's what we expected. So when we run the program, we actually got 3. So it's a match. Now in this one, actually our thing falls into like 1 2 3, these 3 elements. but out of this only 2 of them are correct. So we should get the expected as 2. And then the last one, there is only 1 that is really correct. All the other ones are not matching. So this one we actually successfully tested our little function, and then basically we get 3 expected 3 from the program, and then that's what we got it. Now the next one, which is the front underscore x. So here, as we said, basically the something starts with x, that needs to be sorted, and then that list needs to be appended before or appended before the other list which is sorted to. So here is a string, here is the list, and then the sorted one, what we expect is XAAA, that is the last element, followed by the second to last, and then this, and then BBB, and then CCC. So same thing for the next one, basically it's XAA, XCC, AA, BBB, CCC, and similarly for the third one as well. So here also, like we get OK, and then we got the same thing basically. Finally, the sort last script essentially, which is the number of tuples basically, which is 1 3 3 2 2 1. The sorted one will be based on the last one, which is 2 1 3 2 1 3, and then the same case for 3, and then all the 3 are also like tested, and then we are getting OK. So all these functions really work. So try this out, and then try out also like devise how we can test those functions. So that's pretty much covers most of this one. There are a few more examples that I want to go through, and then I'll probably go through it in the next lecture. Thanks.